Hello there. Today we'll be doing find the largest number in a rotated list. You are given a list of unique integers, nums, that is sorted in ascending order and is rotated at a pivot point. Find the maximum number in the rotated list. Can you solve it in O log n? So let's go through three solutions today. We're going to do a O of n solution, O n log n solution, and O log n solution. So the first solution is rather simple. Return the max of R. This basically searches through the entire array and finds the max. The next thing we're going to do is R.sort, and after that, just return the last element in the sort array. That would be the biggest item. And so both of these would work, as you can see here. So let me just submit that. So we have the solution here. So, but this is not good enough for us. Let's do O log of n. So this requires us to do binary search. And I want to eliminate all the smaller numbers possible, like remove all the smaller numbers every single time we cut the list in half. That's binary sort. So left is equal to 0. So we want to get the whole array first. So left is equal to 0. And right is going to be length of R minus 1. All right, once that's complete, let's set the result to 0 for now. So we want to go through an entire array until the left crosses the right. And we want to set the midpoint to be, of course, left plus right divided by 2. Of course, this could result in an error, out of bounds error if we had too many items in nums, but we don't have to worry about that here because we're under 100k items. So in this first case, let's if we are in the low to high section, let's say low to high to low, this is what's possible. And we're in the low to high section, so let's move, if we're in this section, let's move left up, because if we want to see if there are bigger numbers in this section. And we eliminate everything that's smaller on the left side. So what we want to do, so if num, if R mid is greater than the R of 0, which is our first item, so we're in the low to high section, then we will set the result to equal to the R mid, right? And then we set the low left to be equal to mid plus 1. Afterwards, otherwise, we have to set right to equal to mid minus 1 to eliminate this possibility where we are in the low section. So let's say mid is here, right? We're in the low section, and we want to eliminate that section here, and we want to move the right down. So we want to move the right down and get past all these lows. So in the end of all these operations, we would find out that R would eliminate every time we're in the low section, and the left will always move towards the higher section until they cross. At that point, we should have the mid at our highest point. Let's run the results. We have 0 for some reason. Let's check out what's going on here. Greater than or equal to. Run. Perfect. Submit. And we have a 94.41. So for any of you guys wondering how to make sure we don't get error boundaries, one way to do it is to do a left plus a right minus left divided by 2. So this way we eliminate the possibility of getting error out of bound error. Of course, it's a little slower. And with that, I think we have solved this problem. So it's mainly about eliminating what can we eliminate with binary search problems. So in this problem, we eliminated the smaller numbers, and how we did that was we made sure that whenever we were in the high to low section, we would eliminate all those low numbers, and whenever we were in the low to high section, we would move up to get closer to our high number, and that's how we solve this problem. Alright, so thank you very much for watching. I hope you enjoyed the video. Please like and subscribe, and if you want more videos, please look at the description below for my links. So thank you very much. Have a good one.